Hey everybody, welcome to adding and subtracting in scientific notation. So here in this problem we have 2.1 times 10 to the third plus 4.4 times 10 to the third. And notice on both sides of the problem our powers of 10 are exactly the same. On the left we have 10 to the third power, and on the right we also have 10 to the third power. And this is the only rule for adding and subtracting in scientific notation. Our powers of 10 need to be exactly the same. And if they're not the same, don't stress out. There are ways of still solving the problem, and we're going to go over an example of that later on in this video. So let's get started right away with this problem. Here we're adding in scientific notation, so our first step is to add the constants. We have a constant of 2.1, and we have another constant of 4.4. So we need to add these two constants together. 2.1 plus 4.4. And this is being multiplied by a power of 10, and our power of 10 stays exactly the same. Since we have 10 to the third power in our original problem, we're going to bring that down, and our final answer is also going to have 10 to the third power. And now we just need to simplify this just a little bit further. We have 2.1 plus 4.4 in red. 2.1 plus 4.4 is equal to 6.5, and this is being multiplied by 10 to the third power. This is our final answer. And I want you to take a look at our constant. This constant needs to be between 1 and 10. And notice how we have the value 6.5, which is between 1 and 10. So in my next example, I want to show you what we have to do when this value is not between 1 and 10. So here we have 8.0 times 10 to the fifth minus 7.6 times 10 to the fifth. And notice how our powers of 10 are exactly the same. On the left and the right, they're both 10 to the fifth. So that allows us to subtract in scientific notation. And since we're subtracting, our first step is going to be subtract the constants. So we have a constant of 8.0 and another constant of 7.6. So we need to subtract these constants. We have 8.0 minus 7.6. And this is being multiplied by our power of 10, which stays exactly the same since we have 10 to the fifth in our original problem. Our final answer is also going to have 10 to the fifth. So let's keep on simplifying. In the red, we have 8.0 minus 7.6. 8.0 minus 7.6 is equal to 0.4. And on the right, this is being multiplied by 10 to the fifth power. So now let's take a look at our constant 0.4. Remember what I said in our last example, our constant needs to be between 1 and 10. And 0.4 is less than 1, so that is not good. So what we need to do is move this decimal point so this number is between 1 and 10. And if we move the decimal point 1 unit to the right, then the number is going to become 4, which is between 1 and 10. So our new number is going to be 4. And since we just moved the decimal point 1 unit to the right, that means that we need to multiply by 10, and we need to put a negative 1. We just moved the decimal point 1 unit to the right, so that means you need to put a negative 1 in the exponent. And on the right side, we're still multiplying by 10 to the fifth, and we can actually simplify this even further. We still have our constant of 4, and this is being multiplied by our power of 10. And notice how we have two powers of 10 that are being multiplied by each other. And you can simplify this by adding the exponents. So we have an exponent of negative 1. And if we add that with the other exponent of 5, negative 1 plus 5 is equal to positive 4. So our final answer is 4 multiplied by 10 to the fourth. So now let's go over one more example when our powers of 10 are not the same. So here we have 3.5 times 10 to the fourth plus 3.1 times 10 to the fifth. And notice how our powers of 10 are not the same. We have 10 to the fourth on the left side, and we have 10 to the fifth on the right side. So since they're not the same, this is not okay. We got to change this so the powers are the same. So what I like to do is take the smaller power, which is the 4, and make it the same as the bigger power, which is the 5. So I'm going to turn this 10 to the fourth into a 10 to the fifth. So if I change this into 10 to the fifth, I effectively just moved the decimal point 1 unit to the right. So in order to compensate for this, I have to move the decimal point 1 unit to the left. So the 3.5 becomes 0.35. So instead of 3.5, now we have 0.35 being multiplied by 10 to the 5th. And I always recommend double checking your work. If you take 3.5 and you move the decimal point to the right 4 units, you're going to get the number 35,000. And if you take the number 0.35 and you move it to the right 5 units, you're still going to get the number 35,000. So that's a good way to double check your work and make sure that you're not going to make any mistakes in the middle of the problem. So moving on, our right side stays the same. We have to add 3.1 times 10 to the 5th. And I want you to notice now that our powers of 10 are exactly the same. We have a 10 to the 5th on the left and a 10 to the 5th on the right. So now we can add this just like we did in all of our other examples. So if we take our constants, we have a constant of 0.35 and we have another constant of 3.1. We need to add those constants together. 0.35 plus 3.1. And this is being multiplied by our power of 10. And notice how our power of 10 is 10 to the 5th power. So in our final answer, we're also going to have 10 to the 5th power. And simplifying this even further, we have 0.35 plus 3.1, which is equal to 3.45. And this is being multiplied by 10 to the 5th. And this is our final answer. So I hope this gave you a better idea on how to add and subtract in scientific notation. In my next video, I'm going to talk about multiplying and dividing in scientific notation, so stay tuned for that. I really hope that you are enjoying these videos, and I will see you in my next one.